Hello, Sweden. Hello. How are you? A lot of people are here. Cool. So welcome to my session about index impact analysis. The next hour, I want to show you when we are creating new indexes for our SQL Server database, how we can measure the impact of those index changes, which means, is our performance improving or is our performance even degrading when we are creating a new index in SQL Server. Before I go down to the details, I want to give you few information about my person. My name is Klaus Aschenbrenner. I'm coming from Vienna in Austria. I'm an independent SQL Server consultant. I'm only working with the relational engine of SQL Server, so I have no idea about data warehousing, business intelligence, just the relational engine of SQL Server. Sounds not too much, but it's a huge, big thing within SQL Server. I'm also a Microsoft Certified Master for SQL Server 2008, which doesn't matter anymore because Microsoft has retired that certification. Could happen. I'm also the author of the book Pro SQL Server 2008 Service Broker, which was published by APOS in the summer of 2008. Service Broker is an asynchronous messaging framework that was first introduced with SQL Server 2005, which almost nobody knows, but it's really, really powerful. You can also follow me on Twitter, and you can also find further information about my person on my homepage at sqlpassion.at. I'm also coming back to Stockholm in March, where I'm running my SQL Server performance tuning workshop for 5 days. If you're interested in attending, please come afterwards to me, because I can give you a discount of 10% if you're interested. Okay, let's have a look on the agenda. I mainly want to talk about 4 different topics, so mainly 15 minutes for every topic. Let's see how that will work. In the first step, I want to talk about the double-edged sword of indexing. Who thinks that indexes improve performance? Come on. Who thinks that indexing degrades performance? Yes, you're right. With indexing, we can improve and also degrade the performance of our queries. So the first step, I want to show you how that can happen. And afterwards, I want to show you an approach how we can measure if an index change for our database was a good one or a bad one. So I'm mainly concentrating here on 3 different things. In the first step, I want to show you how we can capture our workload from production. Then I will show you how we can replay that captured workload in an isolated test environment, maybe on a separate server, on a separate SQL Server instance. And finally, I want to show you how simple it is to measure if our applied index changes are good ones or bad ones. Sounds interesting? Perfect. So I'm continue. So what is the biggest problem of indexing? The biggest problem of indexing is with every good non-clustered index, we are improving the read performance, and on the other hand, we are just degrading the write performance. Every additional non-clustered index is just a copy of a subset of our table data, which means when we are changing our table data, when we are making insert, update, delete statements, SQL Server has to maintain those additional non-clustered indexes through the update execution plan. So it's a very bad idea to just index our workload for select queries. You have a really great performance for your select queries, but you have a really bad performance for your update queries. Queries which are making insert, update, and delete statements. I want to show you that behavior with a simple example. So I'm going here to AdventureWorks 2012 and enabling the session option Statistics IO on. With that session option, SQL Server will tell us how many page reads we need for a given query. The next step, I'm running here a simple select statement. So we're requesting some records from the table person.address, where state province ID equals 42. 42 is always the answer. And we're requesting 2 columns. We're getting back 8 rows. When we look on the execution plan, we have here index seek, non-clustered, and the key lookup clustered, because the column postal code is not part of the non-clustered index that SQL Server referenced. Is that execution plan a good or bad one? It depends. When we look on the messages window, you can see we need for that specific query 19 logical reads. We can further improve that query by creating a covering non-clustered index, which means a non-clustered index that includes every column that we are requesting in our query. So what I'm doing in the next step, I'm just creating a covering non-clustered index. So I'm including the column postal code, which eliminates the bookmark lookup, which means when we are running our query again with a simple, nice execution plan, index seek non-clustered, logically reads just 2. Perfect. Let's deploy that change to production. Is this good or bad? Well, it depends. For that query, it's a good change, but imagine we have some other queries which are changing the column postal code. In that case, SQL Server has to change that column in 2 places. Once in our clustered index, the clustered index is our table data, and once in the non-clustered index that we have created earlier. So when we run a simple update statement, beginning here new transaction, because I'm doing a rollback afterwards, and I'm just changing the column postal code. So when we run that query, whoops. When we run that query, you can see we have a nice update execution plan. We are searching for the rows that we want to change. We compute the new values, and finally, we change our clustered index. What you can also see here, SQL Server also has to change the non-clustered index that we have created earlier. Because in the leaf level, we have included the column postal code. We have just duplicated that column. So you can see in the messages window, we need 98 logical reads. To compare the performance of that update statement, I'm just dropping that non-clustered index that we have created earlier. And I'm rerunning the update statement again. As you can see in the execution plan, SQL Server only has to change or update 1 additional non-clustered index. Earlier we have updated 2. And when we look on the messages window, 67 logical reads. That's the double sword of indexing. When we are improving performance for our select queries, we are degrading the performance of our update queries, insert, update, and delete. So it's a really bad practice just to concentrate on one specific statement, try to improve the performance of that specific statement by creating additional non-clustered indexes without looking on your whole workload. Make sense? Okay, so that's the double-edged sword of indexing. Questions on that?
Yes, you say it only improves read queries.
Yeah.
But it can also improve updates and deletes.
Yeah, update and deletes can be also improved because in the first step we have to find the records that we want to change or delete. So from that perspective you are right. For an insert statement, every additional non-clustered index is just pure overhead. Okay? So the question is now how we can measure in an easy automated way if index changes that we have done, if those changes are good ones or bad ones. The solution that I want to show you today is the following. In the first step, we need a so-called baseline. Who of you has a baseline? Nobody. Yeah, almost nobody. Imagine you have a query and that query takes 5 seconds. Is this fast or slow? I have no idea. When the query took yesterday 1 second, it's slow. When the query took yesterday 5 minutes, it's amazingly fast. So without a baseline, without any collected data, we have no idea when we are making index changes, if those changes were good ones or bad ones. So we need in the first step a so-called baseline. In the next step, when we have established that baseline, we can identify those queries which are performing bad and create additional non-clustered indexes for those queries. Then we are deploying those index changes, not to production, maybe to a test system, isolated test environment, and then we are just measuring the impact. So we are running in the first step our workload, then we are making changes, and then we are just rerunning our workload again, and we are just measuring the runtime statistics of our workload. And finally, we can compare if the overall performance is better or worse. When the performance is better, we can deploy that index change to production. If not, we have to think about it. Okay? So let's talk in the first step how we can capture our workload from production. Who of you has a test system? Everyone, yeah. Normally, customers have no test systems besides the production system. So what people are doing, they are just deploying, testing new changes directly on production. That's really, really bad, as you have seen earlier. We have improved the read performance, and in the same time we have just degraded the write performance of some specific update statements. So what I'm always suggesting when I'm working with my clients, that you are capturing your workload from production, and that we are rerunning that workload on a different test system. What you first need here is, of course, a backup of your database. How can we capture the workload from production? Through SQL Server Profiler. Since SQL Server 2008, Microsoft also introduced extended events, but by now it's not possible to gather or to capture our workload through extended events. So by now we have still to use SQL Server Profiler to capture the workload. Okay? The most important step here is that we are not relying on the UI of SQL Server Profiler itself. SQL Server Profiler itself is a badly written application. I have seen systems, SQL Server installations, when you are starting SQL Server Profiler, you're just crashing SQL Server. When you are running in a cluster configuration, you can make a cluster failover by starting SQL Server Profiler. So SQL Server Profiler is really, really bad. But what we can do, we can create a trace through SQL Server Profiler, and that trace can be scripted out into a SQL file, which uses in the background the SQL trace stored procedures. And that's a safe way to capture information from our production system. Let's have a look on that. So let's go in the first step to SQL Server Profiler. Going here to my default instance, localhost. And as you can see here, we have here a replaying template. That template can be used to capture all the relevant information so that we can afterwards replay our captured workload. What we're doing here in the first step, we hit the run button, and afterwards we are immediately stopping that trace. Because running the trace through SQL Server Profiler is a huge overhead to your SQL Server system. Profiler uses a lot of memory, Profiler uses CPU cycles, Profiler uses the inefficient row set provider to display the results that we are capturing. So I'm hitting run and immediately stopping it. What you can do here in the next step, we can export that trace definition. Under the hood, SQL Server Profiler just uses stored procedures which are coming from SQL trace. So Profiler is mainly a front end through SQL trace. Make sense? I have prepared here that script which is exported. I have here the replay trace. As you can see, we are just dealing with specific stored procedures. sp trace creates a new trace. You can supply the folder where we want to store those information, and with sp trace set event, we can capture some events and also the various columns of those events. As you can see here, we are capturing event 78, column 3, column 11, column 12, column 6. Really intuitive, isn't it? No. That's just crazy. You have to go to Books Online to see what event 78 is, what a column 3, 11, 12 is. That's also one of the reasons why Microsoft has introduced extended events. Extended events are just self-describing. This is not self-describing, this is just crazy. Okay? So when we look down here, you can see we're capturing a lot of events. Don't ask me which ones. With sp2a set filter, you can set a filter. For example, SQL Server Profiler excludes himself. You can also filter, for example, for a specific database ID. And finally, with sp2a set status, with the value of 1, we are starting our trace. Which means when we have started our trace also appears in systraces. Finally, when we are finished with our workload capturing, we can take the value of 0 to stop the trace, and with the value of 2, we can delete the trace. Okay? So I'm executing that script, the first step. So we have here a new trace in systraces with the ID of 2. I have here a simple workload generator which simulates an OLTP workload. So when we go to SQL Server Profiler, do activity monitor, which is also again an overhead when you are running it, we will see after a few seconds that we have some activity within SQL Server, and we are capturing that activity with the SQL trace that we are currently running. Okay? So we are just capturing the workload from our production system. Okay? Questions? Are you already amazed? Yeah.
In case you don't have access to the production server file system, is it possible to save the trace, for example, on a UNC path and access?
Yes, you can also save the trace, for example, in a SQL Server table. That's also possible. But when you're tracing to a SQL Server table, it should be a table on a different SQL Server. Because otherwise you're just influencing the workload that you are currently capturing. Okay? Other questions? Okay. So let's stop that. I have already prepared here a trace. As you can see, I have here that trace, and it has around 87 megabytes. We can open that trace again in SQL Server Profiler. When you're doing that, again, yeah.
What is the overhead of running this trace this way?
Minimal overhead.
What is minimal? Like 5%, 10%?
Maybe 2 to 3%. Yeah. The main thing here is that you're not using SQL Server Profiler, just SQL trace. Okay. So as a preparation, I have run here the workload earlier because it took a few minutes. You can see here I have captured almost, no, you can't see it. I have captured here almost 300,000 events. So when you are capturing your workload through SQL trace, those trace files can get very, very, very big. Okay? So that trace that we have captured here just represents our production workload. So what we can do now in the next step is that we are rerunning that captured workload on a different system, for example on a test system. So we can try to make index changes on a different system without influencing our production system. That's the main goal here, okay? We just want to capture our workload from the production system, and with that captured workload, we are doing a replaying on a different test system. Okay, so for our test system, we don't have to fake any workload. We are just taking the captured workload that we have gathered from production. What are the options for workload replaying? Do you have any ideas how we can replay a captured workload on a SQL Server? Sorry? Tuning advisor, yeah, but with the tuning advisor, you're just running your workload, and the tuning advisor makes you some suggestions how to improve that workload. But you're not running the workload physically against your SQL Server. Other ideas? Profiler, yeah. It's a huge overhead. Doesn't scale really well, because Profiler itself can get a single bottleneck. So Profiler itself has mainly a limited use case. Microsoft also provides us the so-called RML utilities. Just Google or Bing for it. Can be downloaded free from Microsoft. And with the RML utilities, you're also able to do a workload replaying. Main problem that we have currently with the RML utilities, that they are not really maintained by Microsoft anymore. They were great for SQL Server 2008, but with SQL Server 2012, Microsoft isn't maintaining those tools anymore. Because with SQL Server 2012, Microsoft has introduced distributed replay. Who knows distributed replay? Few of you? Okay. So distributed replay is just a completely new technology within SQL Server 2012, which is just a new technology which will also replace the replaying functionalities of SQL Server Profiler. As I've said earlier, the main problem with Profiler is when you are trying to replay a huge workload, that single SQL Server Profiler will be a performance bottleneck, which will limit the throughput that you can replay against your target SQL Server. With distributed replay, we can have up to 16 different replaying clients, which means you have up to 16 different physical machines, and those machines are just replaying a captured workload against a single instance of SQL Server. Okay? Which also scales very, very well in comparison to SQL Server Profiler, which will not scale. Distributed replay also supports two modes for the replaying itself, with a so-called stress mode and a so-called sequential replaying mode. Stress mode means we are just hammering our target SQL Server. Imagine you have captured a workload with 100 concurrent users and you want to see how your SQL Server will react, let's say with 500 users. For that question, you can use the stress mode. We're just seeing how far we can scale our workload. And with the so-called sequential replaying, we are just replaying our captured workload as we have captured that workload in production. So for example, when we have a query started at time 0, we have another query started at time 5, that sequential replaying mode will replay those queries as they have occurred in production. So you just have the same identical workload on that server where you are doing the replaying. Okay? So that's very, very powerful. And for that scenario that we are covering today, we will use distributed replay with the sequential replaying mode. We just want to replay our captured workload in the same way as we have captured that workload on our production system. When we are talking about distributed replay, we have to talk about a few new terms. There's the so-called distributed replay administration tool, the so-called controller, the clients, and our target SQL Server, which we are replaying against. So as you can see, we have here the administration tool. The administration tool itself is just a simple console application. Nothing special. It's just a console application. Then we have the so-called controller. The controller is a deployed Windows service. So the controller just coordinates the various clients that we have. As I've mentioned earlier, we can have up to 16 different clients. In our scenario, we're just using one client. So when we are starting the replay, the controller distributes the captured workload across the various clients. When the various clients have received their workload, the controller starts the replaying itself and just coordinates the various clients, and the various clients are just submitting the queries in the right order with the right timing to the target SQL Server. In our case, to a SQL Server on a different instance. I'm just faking here a test system. Okay? When you want to use distributed replay, you have to install it. So it's not installed by default. As you can see here, you have here during the installation process a distributed replay controller and also a replay client. So when you install distributed replay in a distributed scenario, you need one machine with a deployed controller and up to 16 different machines where you are installing the various clients. In my case, I have just one virtual machine. That virtual machine has the controller and also the client deployed. Most important thing on the machine where you are running the administration tools, that we have seen here, those console applications, here you also need to install the management tools basics. They are just needed so that those administration tools of distributed replay will work. Bad thing about distributed replay, there are no wizards, just XML configuration files. Really, really crazy. Okay, so we have no UI support, nothing, we are just dealing with console applications, we are just dealing with XML configuration files. That's really, really bad. And it's also not changing in SQL Server 2014. Okay. As you can see, with various configuration files, one configuration file for the controller, which coordinates all the various clients, with a configuration file for the client itself. And finally, we have two configuration files which are driving the replaying process itself. When we are starting the replay of our workload, in the first step we have a so-called pre-process phase, which just distributes those events that we have captured to the various clients. This pre-process phase can be configured through a configuration file, and finally the replaying itself has also its dedicated configuration file. They are all documented in books online, but as I've said, it's just XML. Don't expect too much here. So in the first step, we have to prepare our captured workload. As you have seen earlier, we have a DRC file, around 80 to 90 megabytes. In the first step, we have to run that trace through the so-called preparation phase, which means the trace will be converted to a format so that we can use that captured workload through distributed replay. That's the first step that we have to do. So you can't feed directly a trace file or a trace table into distributed replay. You always have to prepare it in the first step. We have here our administration tool called dreplay.exe. You're specifying the mode, pre-process. You're specifying your input trace file and an output folder. That output folder finally contains the converted trace, which is able to be replayed through distributed replay, and the replaying itself is done again through dreplay.exe with the mode replay. You are specifying your target SQL server, your input directory from earlier, and finally with the W parameter, you can specify up to 16 different clients. So that's the main advantage of distributed replay, that you can have up to 16 different clients which are coordinating the replay through the controller itself. SQL Server Profiler, when you are doing a replay, you have just one client, and when you are replaying a huge workload, that client can be a single point of bottleneck. Okay? So let's have a look on that. Sounds complicated, is almost easy. So, I have here a simple text file with the various comments that we need. So what I want to do in the first step, I want to prepare our captured trace that we have here so that we can use it for distributed replay. So let's call dreplay.exe pre-process. We specify the input file, the captured trace. Replay TOC, and we write everything to C temp. As you can see, the replay itself started, when you run those pre-preparation phase, don't do it on your SQL Server itself. Because again, it consumes memory, it consumes CPU cycles. So you're just copying that trace file that we have captured from production to a different machine, maybe a development machine, a workstation. On the workstation, we're just preparing the trace itself. This runs now for around 2 to 3 minutes, and when we have finished, you can see the output are just 2 files. And those 2 files are used afterwards by distributed replay to drive the replaying process itself. So we have here an XML file which contains some metadata information about the captured or converted trace, and finally we have here another file, IRF, which contains the events itself, which can be replayed through distributed replay. Make sense? As you can see, it takes some time, 25%. Let's stop it. We have here already those files prepared. So what we can do in the next step, we are now just replaying that workload. As you can see here, we are using dreplay.exe with the mode replay, and I'm specifying here a different instance of my SQL Server. With that different instance, I'm just faking a test system. Okay? So as you can see here, in Object Explorer, I have here an instance 1, and I have here already prepared the database. It's the same database as on the default instance, the same database as on production, and I'm just replaying the workload against that test system. Okay? So with the S parameter, we are specifying our target SQL Server. With the D parameter, we are specifying the output folder where we have the trace preparation. And finally, with the W parameter, we are just specifying our replay clients. In my case, I'm using the replay client of the local machine, localhost, so I'm using here the name of my machine, which is perf tuning. Okay. So let's run that. dreplay.exe, replay, perf tuning, instance 1, temp. So as you can see in the first step, distributed replay dispatches those events to the clients. In my case, to my local client. That's the first phase. And in the second phase, the replaying itself will start. So I'm just opening here the activity monitor of instance 1. And after a few seconds, you will see again that I have some activity on that instance. So what we have done here, we have taken our workload from production, and we are just replaying that workload in the same way on a different SQL Server, on a test system. Okay? As you can see, the events are dispatched, and in a few seconds, the replay itself will start. Questions on that in the meantime? Yeah?
Can you take a trace from 2008 and run it against 2012?
Yeah. Yeah, it will work. Question in the back?
I think it was the same trace. Did you ask about if it's possible to run it against 2008?
Yeah, you can also run it against 2008. That's no problem. Question here?
Can you run the replay on an empty database?
No. No, you need, of course, a backup from production. Because in the captured workload, you have your select queries, Okay, that's fine with an empty database, but you also have your write workload, insert, update, delete. Imagine what happens when you're making a delete against a record which is not present. Nothing happens. Or imagine you're making an insert into a table with a key which already exists. So when you're capturing your workload, you also have to make sure that you have a consistent backup, which will work with the captured workload. Okay? So as you can see, we have now our activity within the different SQL Server instance. 15 minutes remaining. Those are just Microsoft minutes. So they will go down very, very fast. As you can see, 4 minutes. So just Microsoft minutes. But as you can see here, it's very, very easy to capture a workload and just replay that captured workload on a different system. Imagine now, on our instance 1, we can make now index changes in an isolated environment. We are not influencing our production workload. So that's the main goal here. Okay? We are not influencing our production workload. We are just making our index changes on an isolated test environment. Make sense? Question?
Could we have a look at what the XML files look like?
Yes. So that's just an XML file with some information. As you can see, you have here the several speeds, the session IDs. In my case, I have run the initial workload with 32 users. So you have that information. And then the other file with the 71 megabytes, I don't want to open that with Notepad, takes forever, trust me. We have just the events itself in a proprietary format. Okay? Other questions?
I wonder how you synchronize your target system before you replay. You mean you have to take a backup exact moment when you start the
Yeah,
trace?
yeah.
So if there are many transactions, you will hit the key exactly as
Yeah.
you think it should.
Yeah. Normally, when you are capturing the trace, you are also preparing that trace. For example, you import that trace in the SQL Server table, and you are just deleting those events, those queries which should not be part of the replaying, so that you really get a consistent point in time. So that's the trickiest part, that you synchronize the start of the captured workload with your database backup. But again, we are doing that in a completely isolated environment. We are not influencing our production workload, so it's almost easy. Maybe a little bit time consuming. Okay? So as you can see, we were finished. So we have now just replayed that workload on a different instance, on a different system, on a different test environment. Okay? So by now, we have done all the prerequisites so that we can make index changes in an isolated environment. Imagine now, instance 1 is our test system, and now we can play with our indexing strategy. We are measuring the performance of our queries before we make the index change, then we make the index change, and afterwards we measure the performance again. The question is now how we measure those runtime statistics of our queries. Any ideas? DMVs, yeah. You can also use SQL Server Profiler, extended events. Question is, when we have two runtime statistics, before we have done the change, afterwards that we have done the change, how we correlate both to each other. That's the main problem, the main question here. Of course, you can capture several traces, you can capture dynamic management views and so on. correlate your queries manually between both captured information, but trust me, it takes forever. It's just painful. But we can do that completely automatically. There's a tool available called QAnalyzer, which you can download from the company DB-Sophic. It's completely free. And with that tool, you capture runtime statistics of your queries, and afterwards you can compare those runtime statistics. The runtime statistics before we have made our index changes, and the runtime statistics after we have made our index changes. Looks like that. Red means our performance degraded, green means our performance improved. So it's very easy to tell for your workload in which areas a specific additional index improved the performance of our queries, and in which areas that index degraded our performance. Okay? Let's have a look on that. So I have here that QAnalyzer. Costs nothing. It's a free download. They don't call you. It's just nice. The first question is which runtime statistics we have to capture. When you have installed that tool, it goes to C program files x86, DB-Sophic, QAnalyzer, and here you have trace templates for SQL Server Profiler. So with those trace templates, they are just capturing those information that the tool needs to correlate queries against each other and to calculate the runtime statistics. Logical reads, logical writes, elapsed time, CPU times, and so on. So when you double click on that template, you're just registering that template within SQL Server Profiler. So when we go to new trace, against the SQL Server instance, you can see here you have a new trace template. So when you're replaying your workload, you're doing the same thing. You're replaying the workload, and in the background, we're just running a SQL trace with that trace template. And that trace template just captures the relevant information which is needed by that tool to compare the impact of index changes. Make sense? Okay. So mainly, you're doing the same. Run and stop. You're exporting that trace definition, and finally, you can open that trace on your target SQL Server. For example, in my case, instance 1. Okay. So as you can see here, they are capturing event 10. No idea what event 10 is. Event 12 and so on. And the same thing again. You're starting your trace with sbtrace set status, value of 1. Finally, you can stop it with the value of 0 and delete it with the value of 2. Same thing as we have captured our workload earlier in production. As you can also see here, I have here now 2 traces. Those are the traces which I have run when I have made index changes. So those are the traces which are suitable for QAnalyzer. As you can see, I have a before trace, my initial performance. Then I have made index changes, rerun my workload, and captured the runtime statistics of those queries in the after trace. So we have now 2 traces with runtime statistics of our queries. Okay? So what we are doing here, going to the tool, we are making a new workload analysis. They need a SQL Server database to do that analysis. So let's create a new one. So I'm creating here a new one on the default instance. Let's call it workload analysis. Workload name before workload. Okay. And now we are just importing our initial trace with the initial runtime statistics. So we add our trace file before. Here you can configure analysis options. When you're just comparing runtime statistics, you can leave it as it. Now we're importing that around 90,000 events. And then they open a workload summary, which provides you general information about the captured statistics of your workload. As you can see, you have here the duration. So you can see that workload was running for around 7 to 8 minutes. You have your CPU time, your reads, your writes, how many rows you have returned. You have your top consuming batches, top consuming databases, top consuming servers. So you have already with that summary information a lot of information about your workload in your hand. That's already amazing that you're getting here just for free. Okay? It gives you a better picture, a better understanding of your workload. Okay? So that's our initial baseline data. Then I have made an index change and was just rerunning my workload again. So what I'm doing, I'm importing the second runtime statistics. So again, localhost, I'm using the same database after workload. And I'm just importing the other trace file. Again, around 90,000 to 100,000 events. It's the same workload, just with a different indexing strategy. So you can really play with your workload and find out when you have found the best indexing strategy for your specific workload. Again, we have the workload summary, and now we can make a compare to baseline. So we are just comparing both workloads against each other. And the tool will tell us afterwards in which area, for which queries the performance was improved, and for which queries the performance was degraded. So we compare to the before workload. And as you can see here, red means bad, green means good. You can see here, I had here one query where we have around 1.5 million reads less. I have just eliminated a bookmark lookup for recovering non-clustered index. The same as we have done earlier in that VentureWorks database. You can see the duration of that query took around 10 seconds less, CPU times around 70 seconds, and you can also see we have run that query for around 1,000 times in our workload. Okay? So we have improved the performance in one specific area, and of course we have degraded performance, the double-edged sword of indexing. We have improved read performance, we have degraded write performance. As you can see here, we have a different query. That is, of course, some update query, insert, update, delete. You can see we had here some writes. You can see the duration of that query, of all queries, around 1,000, around 23 seconds more. We needed around 190 milliseconds more. we had more reads and we also had more writes, around 98% more. Okay? But that's really, really powerful. You can see in one picture in which areas additional or indexes that you are changing will improve your performance, like here, and in which area your performance will just degrade. How do you like that? Good, bad, doesn't matter. It makes your life as a DBA or even as a developer just easier. Because
is there an aggregate as to increase and decrease in performance, so you can see the total sum or something?
No. Yeah. What I'm normally seeing at customer side, my customers, are just deploying index changes, and their customers will tell them afterwards via phone if that index change was a good or bad one. Good one means nobody calls them. Bad one means, my SQL Server is so slow. With that tool, and with the technique that I have shown with workload capturing, workload replaying, you can do that completely in an isolated environment, and you can really see very easy when you make one index change in which areas I'm changing the runtime statistics of my workload. Okay? Question?
Is the SQL source statement available in there?
Yeah. Currently, I have here everything captured on a batch level when we have imported that trace, but you can also break it down to the individual statements. But you don't need that for the comparison itself. But you can really import it on a statement level and further investigate the statement that were executed against your SQL Server. So it's also a very handy tool to get a better understanding of your workload. Okay? Questions?
In the beginning, when you create the trace file
Yeah.
for the workload, you use a template, right?
Yeah.
Was that a special template?
It was the replaying template of SQL Server Profiler.
Is that the default one?
Yeah, it's just the default one. Yeah. So it's the default one which is shipped with SQL Server Profiler. And the other one is shipped with the QA analyzer. You just have to double click within the file system, that then it gets imported to SQL Server Profiler, and afterwards you have to use that template to capture the necessary runtime statistics so that you can do afterwards that nice comparison. Okay? Cool.
How many runs can you compare?
2. Yeah. So normally you capture your initial baseline, you make some changes in your workload. Maybe it's not an index change, just imagine you want to test how SQL Server reacts with your workload when you're giving SQL Server more memory, or when you're changing some server options, for example, cost threshold of parallelism, max TOB, and so on. You can use that technique for just everything. Okay? It's not restricted to index changes. Okay? It's perfect for index changes, but with the other counters that we have seen, for example, duration, CPU time, and so on, you can also use it for other things to find out how SQL Server behaves when you are changing some configuration options. But you make your change, then you compare again. When it was a good change, you can apply that change. When it was a bad change, you're just reverting and you try something else. Okay? So it's just an iterative process to make your SQL Server performing better. Okay. How do you like that session? Cool. So summary. The first step, I have talked about the double-edged sword of indexing. As you have seen, it's a bad idea to just add additional indexes, non-clustered indexes, to improve the read performance, because at the same time we are just degrading write performance. Afterwards, I have shown you an approach how we can capture our workload from production, how we can replay that workload on a different test system, and finally, how we can measure changes that we have done to our indexing strategy or changes that we have done to our SQL Server, and to measure if those changes were good ones or bad ones. So, thanks for attending. It was really nice to present the first time here in Sweden. It's the first time that I was here. As I've already said, I'm coming back in March for my SQL Server performance tuning workshop, 5 days. If you're interested to attend, just come to me. When you give me your business card, I can give you a 10% discount. So thanks for attending, and enjoy the rest of the SQL Valley conference and the rest of your life. Thank you.